Hello everybody and welcome to another Advent of Code video, this time with day 13. So today we'll be solving a distress signal and we'll be decoding it. But the issue is that the packets are in incorrect order and we will need to identify how many are in the right order. So this is the sample input. And each packet of information consists of lists and integers. So a list can contain sublists like this. And we will get those packets in pairs, and we will be comparing those pairs to see which is which comes first. So if we're comparing two values, the single integers, then the lower integer should be the one that comes first. If both are lists, then we compare the first value and second value and so on. If the left list runs out of items first, then the inputs are in the right order. If the lists are in the same length, then we continue with the next part of the input, and if exactly one value is an integer, then we convert that value into a list and we compare as if we are comparing lists. So that makes sense. Okay, so let's try to implement this. I've already prepared the project for this with the input file here. So now let's try to build this. So what we'll need in this case is a class for the packet, and we will need two types of packets. So abstract class packet. It will be IComparable because we will need to be able to compare two packets. So that's gonna be implemented here. So if other is null, throw like this, and then we will implement some logic there. So that's to do. Now we will need two different classes. One is class list packet. It's just a packet which contains a list. So contains a list of packets, and there will be also a class value packet which contains just a single integer value. Well, let's make it read-only for now. So that's that, and we will also have a constructor here. Oh, we don't need the constructor per se. We just make this read-only and initialize it with empty list. Okay, so now we'll need to parse the input somehow. So we will have a static packet parse input. This will read the input line, so to speak. Let's just read the input. We will have a reader like this, and we will be reading the lines. So while read line, If we read one packet, we will read the second one. And after each 2 packets, there is an empty line, so we'll do just... Alright, it can be... Okay, let's do it like this. This for the empty line, and then we will parse them. So these are not going to be null because of the input's validity, and then we compare them. Okay, 2, and if we compare them, then we need to... Our goal will be, what are the indices of pairs that are in the right order? It's indexed from 1. We'll sum those which are in right order, so that means that and current index. So like this, and if the packet 1 is lower, then it means that this comes first, so the correct index sum plus equals current packet, like this. So this will give us the sum of those which are in the right order. We output that. So this is the first part of the problem. But what we need more is, we need, of course, implement the comparison and the parsing itself. So for the parsing, we need to first determine if the packet is a list packet or a single value or single, like this, single value. So if input starts with this, then it's a list packet. Otherwise, it's a value packet. So if it's a value packet, then we will return just. Well, technically, we want to be able to like read the whole thing in a nested way by recursion. So maybe let's create a separate method also. We'll take the input with this, and we will parse it. Right, we need to have some variable for that, so so now we'll be reading the whole thing, and instead of this, we'll start to connect to our current position. So if we're on a opening bracket, it's gonna be a list packet. So variable may switch the order like this. So if put current position is if it's a digit, so If it's a digit, then we'll return so if the current position is a digit, we'll read until we've hit something that's just not a digit. So current position. While we're on a digit, we will increase the index, and then the end will be then when we're on the index after the last digit, so we'll now parse it. So number parse string input substring. So we take the input substring from start index, so to current position minus start as the length. So if it's 1, then it's, yeah, that makes sense. So we have the number and we return the number packet or value packet, how it calls value packet. And if it's not a number, then it's a list. So we'll create a new list. We'll increase the current position. And then we will be reading the items one by one. So while we're not at the end of the list, we'll parse input current position. All right, and it's ref. We'll add it to the list. So item, or like this. So we will be adding the items, and always there is a comma separation between the packets. So when the inner packet hits the closing bracket, it will return and it should we should be ending at the position after the end. So current position plus plus. So if current position is a comma, we just jump to the next one, and then we parse inner, and so on and so on. That should be hopefully enough. Yeah, seems like it. So let's just see if this works at least somehow. So we'll let's just verify if this works. So put this here and run it. So packet 1 is right. Need the parsing part. So packet 1 is list packet of 5 items which are values, which is correct, and the second one is also list of values. That makes sense. So that's kind of a simple example. Let's just ignore this and try to see if we can parse the whole file. That seems fine. I'm interested in this one, which is quite more complex. Now it should be list packet of 2 packets. One is with one value of as 1, and one is of 3 packets of 2, 3, 4. Okay, that seems like it works. So we have the parsing and now the comparison itself. So for the comparison, we just need to implement the rules that are defined here. So if both values are integers, then we just return a compare to value. We compare the values directly. If both are lists, if one is integer, then we convert. So let's convert them immediately because yeah, it's gonna be simpler. So this is list. List, otherwise new list. Oh, no, I don't want to print this. Packet with right. Like this, should be fine, hopefully. So we'll just create a list packet with initialized with this single item, which will be a value packet because there are just 2 different types. Other list is gonna be exactly the same thing. So other list. Okay, so now we have 2 different lists and we'll just do the comparison for lists. So index. We will go one item by item. So while so while our index is lower than the count, because if we have stepped outside of the list, then we return -1 because the first list is oh right. We need to handle both cases. So if list index smaller or list, yeah, while we're inside both lists. So we must be able to find that index in both lists. So, but if not, if we're not able, then we will have to see if the number of items in this list is smaller than in the other. Actually, we just do this. So if both the lists are the same or have different number of items, then the number of items matters. Let's see. Oh yeah, yeah. So if the number of items in the right list is bigger than, smaller than the order is incorrect. So this is what we need exactly. And now the comparison itself. So we take item. So and compare. If it's not 0, and if they are not the same, then we just return the result. And that should be it. Yeah, of course, and in the end we have to increase the index. Let's run it. 13. I think that could be correct. 13. Good. All right. So let's use the big input. And the result there is 5,506. Okay, that's correct. Right. So we have the first part of the problem solved. And now for the second one. We need to put all the packets in the right order, ignoring the blank lines, and also include 2 additional divider packets. So we're just now ordering all the packets. And our decoder key is multiplying the indices of the divider packets then. Alright, so it's gonna be just a slight modification, nothing too major. Let's quickly do this. J13.2. Place. And now the reading of input will be a little bit different because we need an array of packets. Get all the packets at once. So 1, let's add packet 2. This will no longer matter. We'll just read until the end. This is not interesting anymore either. Now we have the divider. So it's gonna be packet parse. Now what's the divider look like? Selected. The second divider is this one. We add them into the list. And now we'll use the magic of .NET BCL to order it. We'll use sort, and that uses the built-in default comparison, so that's IComparable. And then we can do divider position. It's not index because that would be 0 based. This is 1 based, so the same for second divider. This is an in place sort, right? It's in place, yes. So now we console right line divider 1 position multiplied by divider 2 position, and that should be all that's needed. Well, just for safety reasons, I will use this whole simple example. so that we don't make any basic mistake. Run it. 140, that seems correct, so I will copy the full input and run it. And we have 21,756, which is correct. Okay, good. So we have solved day 13 of Advent of Code, and I will now just push the changes to my GitHub repo. So day 13. So you can find it there and test it locally. And thank you for joining me for this day of Advent of Code. You can subscribe to get notified about new videos, and I will see you in the next day. Goodbye.